Namaste and welcome back. Today I have a very hot topic to be discussed with you, that is failure of highway bridges, causes, remedies and future trends. You all have been reading news of various bridge failures in states of Bihar, UP and many other northern India states where monsoon rains are now lashing through. To discuss that, I have two super specialists with me joining the discussion to take you through how the conventional methods are being used, how better designing can help, and how underwater remote operated vehicles can be used for foundations checking, and how drones can be utilized for monitoring of remote bridges. Let's move to the discussion room. So let me welcome our panelists today. First and foremost is Mr. BP Awasthi, former Principal Executive Director of Research, Designs and Standard Organization of Indian Railway, virtually monitoring the entire bridge ecosystem of Indian Railways. And then I have Mr. Pramod Kumar, former Engineer-in-Chief, come Head of the Department of Public Works Department of Uttarakhand State. Now let me come to our first question on the table, that is, what are the common causes of failure of road bridges, and what could be the indicators leading to such failures, and how a good maintenance policy, or what you should suggest to have a good maintenance policy to avoid such events of bridge failure. Mr. Awasthi, would you like to take it on?
Thank you, Dr. Bana. When we talk of a bridge as an infrastructure asset, it is a very typical asset in the sense that it is designed for almost 75 to 100 years of life, the structural life, and for that even the hydrological studies, etc., are also done with a return period of about 100 years plus. So when we talk of a failure of a bridge asset, then it has got two components attached. One is the design part of it, and another is the maintenance during its life cycle. And both are important. And in fact, more care is taken at the design stage, as I see as of now. But during maintenance, during its lifetime, the proper maintenance practices, proper monitoring of its behavior during its lifetime is at times missing. We will have both the perspective, the railway bridges and the highway sector bridges. As a very experienced panelist, Mr. Pramod Kumar is also here, and he is into the highway sector and road sector from the state government side. When I put it from the railway sector, we put a great emphasis on the lifetime monitoring, which is inspection regime, then analysis of those inspection with respect to what is the performance parameters for that bridges, and then subsequently any preventive maintenance, corrective maintenance, etc., to be taken. When we talk of, if I may just mention the recent bridge failures, a couple of bridge failures which I noticed were not that big of bridges. They were relatively smaller bridges. But at the same time, one of them I remember was even canal bridge, but the abutment had failed, which is a clear indication of lack of proper inspection during its lifetime and then proper care at the right time. Let me tell you, the bridge gives adequate warning before it fails. It is not that it fails overnight, whether it's a steel bridge or a concrete bridge. So the two things are very, very important. Whether we have a predictive maintenance regime or a preventive maintenance regime or a corrective maintenance regime, and what I see these days as shortcuts is a failure retention. That's how the failures happened, and then we are talking about it at the moment. So we will elaborate during our further discussion about the design stage precautions and life cycle maintenance precautions that need to be taken. At design stage, we may have, in addition to structural design, hydrological studies to be done. then various earthquake analysis, seismic forces to be taken care of. So there can be various parameters.
Okay, thank
Thanks.
you. Thank you, Mr. Awasthi. Mr. Pramod, could you throw further light on this with your huge experience in highways and as head of the Public Works Department in Uttarakhand?
Thank you, Mr. Bana and Mr. Awasthi. I 100% agree with what Awasthi ji have said. I have worked in the National Highway Authority of India as well as in Uttarakhand PWD. So, as far as Uttarakhand is concerned, this topic is very relevant in the light of this failure procedure. So, in Uttarakhand, actually, rains are very heavy, heavy to very heavy rains occur here almost every day. And during the rainy seasons, it is very difficult to save our roads and bridges. So, as far as I feel, the most important part which pertains to bridges in Uttarakhand is that when the river flow in force, these bridges just wash out, and that is due to main reason is that due to settlement of the substructure. So the substructure should be designed properly in respect of Uttarakhand, particularly I want to say. So settlement which may be caused due to various reasons, inadequate design is also one of them. And during design, actually, we should focus mainly on geotechnical aspect as well as geological conditions also. So geological investigations as well as geotechnical investigations should be carried out in detail. Because here geology plays a very important part in the design and of course construction also. During construction also, many of the things are to be taken into account because the geography is very tough, and in these tough conditions, it is very difficult for the new contractors or the inexperienced engineers and contractors to work over here. So I just want to elaborate few points that inadequate design and type of foundation is one of the reasons which causes failure in Uttarakhand. And lack of proper geological and geotechnical investigation is also one of them. Faulty construction, lack of proper quality control and maintenance, these are also very crucial things. And protection work, which is the main thing. Protection work should be designed very cautiously because most of the PRs, abutments, they fail because of inadequate protection works. And what we feel is that when we submit the estimates to the higher authorities, they just cut the provisions due to cost savings. So my submission is that the protection work is of most importance, and because of silting and discovering, etc., our piers and abutments, they got damaged. So these factors should be taken into account.
Thank you. Thank you, Mr. Pramod. That were very elaborate and detailed points you have given. Now, let me ask Mr. Awasthi as to how you think and what you have seen in your structural analysis and all that the fast moving water currents impact bridge structure, and what design imperatives you would identify which should be focused more to ensure the uh, survivability of the bridge increases when it is constructed.
Actually, on when you say fast moving river waters, I am excluding the canal bridges over here because canals also have fast moving waters, but they are either most probably now they are lined canals, most of them, quite large number of them, and they are much smaller in span. So I'll not talk of that. So talking of river waters, what Mr. Pramod just now mentioned a very relevant point was with respect to the foundation design. There can be three types of foundation which we see: open foundation, well foundation, and pile foundations. So when we talk of river waters, it's traditionally open foundations are not really relevant over there, and traditionally we had been having well foundations over there, but Of late, I am finding that people are resorting to the pile foundation, while pile foundation has got great limitations. Well foundation, in case of well foundation, the speed of construction is not as much, and as the today's era is that काम को जल्दी करना है, right?
Exactly.
Do it yesterday. It should have been done yesterday, types of things. So, on that is where the safety gets compromised, and at times there are pressure on the designer also that why well foundation, do pile foundation, and then integrity of pile foundation itself becomes a question mark. The testing of the pile integrity is also another technical area, and nowadays I'm finding, because of the so-called pressure from the management or non-technical management, there is an inclination towards pile foundation, whether it suits that particular location or not. So that is where at the design stage it is extremely important that we choose the correct type of foundation. If it is well, it is well. It's all right. It is not that a working agency or a contractor or somebody wants pile foundation, so we should put it. No, the correct design wants well, now let it be well. One part. Second part, at times to reduce the cost, as Mohanji mentioned, that we tend to compromise on the protection runs, whether adequate guide runs have been provided or not, proper wing rail is there or not, launching apron is not or not over there. There I have seen many non-technical managerial decision makers will question, अरे इसको अभी लगाने की क्या जरूरत है, बाद में लगा देंगे. You know, that is something is like compromising with the safety of the bridge or design of the bridge right at the step number one. So that is one thing which contributes to the this thing. And then hydrological studies are extremely important. Nowadays, technology has improved a lot. We have underwater inspection, ROV equipments are available. Then Central Water Commission and irrigation authorities, canal authorities, and all those authorities have also upgraded themselves. So if we want that design data for hydrological study is available, even technology is available, equipments are available for detailed hydrological studies, and that is a must to be done. And of course, the return period for whether it is for earthquake or return period for the flood, that should be properly taken care of while designing this. So, nutshell, at the design stage, we should not compromise. And in design stage, there's another factor which also comes in, that we have a tendency of designing it at the margin. Of course, there are safety factors provided in the codes and manuals. Those safety factors are taken care of. But even beyond that, all these bridges, and especially rail bridges, are having uh, great impact of the fatigue life. So fatigue life in the bridges is extremely important. So duly taking care of the fatigue life while designing the bridge is very important, and more so for the railway bridges which is passing over the river. And because over there axle loads are much higher, and fatigue life becomes even much more important. So in railways, we had a practice of keeping even additional safety margin vis-a-vis what is given in the code. But now, with due respect to the PPP, what we are finding here is that many construction agencies and companies, when it comes to EPC model, not the BOQ model, in EPC model, there is a tendency to build it on, design it on the margin. I mean, that is one thing which should also be adequately taken care of at the design stage.
Thank you. So let me come to Mr. Pramod. Mr. Pramod, now that we are in the technology age and everything is now changing and now new ideas, new materials. So, what are the advancements in the materials and construction technologies and any other monitoring technology which can help in better design, construction, and survivability or cost optimization, life optimization of the bridges?
Yes. See, as far as I feel, we should try to design maximum span bridges. I mean, as longer span as can be done, they should be designed. Concrete bridges are quite heavy structures, basically. So, in hilly areas, we generally go for the truss bridges or the suspension bridges. Here in Dobra Chatti also we have made a 440-meter single span suspension bridge, which happens to be, I think, India's longest suspension bridge over here. So my submission regarding this is that there are so many options. Modular bridges are also there. We can go for that, and suspension bridges is there. Arc bridges are there, and trusses are there. We can provide longer spans using these materials, and not only we should go for these concrete or pre-stressed bridges because they are quite heavy also. So these new things may be tried out as far as I think.
Anything you would like to say on the ultra high performance concrete usage?
Yeah, that can also be done, but we have not done it so
I
far.
tell you, this
Can I can
National
I intervene?
Highway Authority has tried ultra UHPC concrete on certain limited spans.
No, I was just saying
Please.
that you have recently undertaken lot of
Yes, please.
electronics based monitoring of the bridges, especially the river bridges. Would you like to throw a little light there in addition to the ultra high performance concrete you were mentioning just now?
Yeah, this is where, in fact, I wanted to bring it earlier also. See, when we say a bridge asset to be monitored in its lifetime, the designer itself prescribes, in especially in case of a steel bridge, which are the critical members, where the stress ratio is the highest, right? So we should be installing the adequate sensors, the strain gauges and all, and we can do the monitoring. In fact, it's a live monitoring which can be done, and which will tell us that at up to what stress level various members of that bridge are being subjected to. I mean, one such system which we did was on the Jubilee Bridge in Calcutta, and now it has become almost a norm. Slowly, it is becoming a norm that on all on mega bridges we have to have such monitoring system. One, this is a component level monitoring during the life cycle. But apart from that, for a bridge lifetime monitoring, we have to have a proper now IT enabled application to monitor its important design features which were incorporated. Then, secondly, various inspections which are done by the field engineers, and subsequent to that, they are monitoring whether the observations given in any inspection have been complied with or not, or what is the pendency. Or I'll give you an example, just a ballpark name. We should have a bridge management system, which can be a web-enabled IT application, which will have its, the user app front end user interface on the laptop or on a tab or on a mobile, and we should capture all the events, all the inspections, and then compare it with the performance parameters of that bridge, and then monitor the implementation of the repair part or whatever activities are to be done. Secondly, from the foundation perspective, whether it is wells or piers, whatever, then underwater inspection should be carried out as to what is the condition below the water, right? Normally that gets neglected, especially in the fast moving rivers in the mountains like Uttarakhand, which
Yeah.
Pramodji mentioned. There normally you have a very fast current. So there may be some special techniques you'll have to be thought of to monitor the underwater condition of the component substructure and foundation, how it is to be done. For relatively not so fast moving bridges, we can use divers, or now we have ROVs, remote operated vehicle, which go inside and then they capture the photographs, high resolution photographs, and the video, and which can be subsequently analyzed by the engineer in the office to assess the condition of that. Then there is one more thing. There was a very good practice earlier that we were getting from rivers, CWC, periodic messages and telegrams of the water level, how much water they are going to release, and all those things. Somehow that has got in disuse. So this linkage between the different departments in this era of communication is very, very important. It can be very easily established. Let me tell you, even in Two, I used to get in monsoon the telegram message from different river authorities that this from this dam this much water we are going to release. They'll send it to all concerned, so they are alert. Then there's another technical input which we need to do is water level monitoring systems on various important river bridges, which will automatically keep on sending the messages to the maintenance authorities that water level is this much. And especially in monsoon, if it crosses danger level or it is approaching danger level, then it will give warning, and then we can put people in place as to whether traffic is to be stopped or some precaution is to be taken. That type of monitoring systems needs to be put in place.
Thank you. Thank you, Mr. Awasthi. And my last question to Mr. Pramod is that as road users and the local communities, what role, best role they can play in ensuring the bridges remain well maintained and the failure indicators are picked up in time and somehow the failures do not happen. What's your experience or advice on that, sir?
Yeah, definitely. See, road users play the most crucial and important role as far as the inspection, or they are the basically first-hand users and informer also. So, road users, local community can play a most crucial and important role in ensuring the regular maintenance and failure detection system there, because they are the first to notice it. They can be guided, educated through media or whatever means we have. That if you see any irregular things or cracks or tilt in the you call it crash barrier, or any level difference in the adjoining spans, or they if they notice any unusual things, they should promptly inform the competent person, and the means are available as on today. They are there. We have apps also available that they can just take a photograph and send it on the app, and we can just take the remedial measures whatever we like. So their role is the most important one. And even if they notice a small hair crack or any irregularity, slight tilt in the crash barrier, level difference, whatever they unusual things they notice, they should immediately report to you so that corrective measures could be taken. And what I feel is that for the safety of bridges, the encroachment should be avoided along the rivers. And the very important thing, one more thing is that dredging, irregular dredging or uncontrolled dredging or mining should not be allowed within almost 500 meters distance of the bridges. Because in Uttarakhand, most of the bridges fall due to these reasons also. Nearby to the piers or abutments, the irregular mining is there or dredging is there. People take out the boulders and aggregates from there, and they scouring occurs in the foundation failure.
In long and big mega bridges, there are many areas which cannot be inspected manually by an inspector or a field engineer. So that is where a technical input of using drones for doing the inspection of inaccessible areas. And we have used it successfully. We have built up a model, and now we are going full throttle on this.
Thank you, sir.
In mega bridges, either somebody inspects from the top or somebody goes at most by a boat or a steamer, and he cannot do the complete inspection. So that is where high resolution photography and high resolution video capturing by a drone of those areas which are otherwise inaccessible, that helps a lot. Even the bearing area can be seen from the bottom, everything can be seen. So that mode of inspection should be used.
Thank you.
Thank you.
Thank you. I especially thank both of you for bringing such wonderful insights, technical details, and we will certainly benefit it. And once again, thank you very much. Thank you, viewers. I'm sure you found it interesting, and if so, then keep viewing, and I'll be soon with you with another interesting episode. Till then, once again, thank you and have a good day.